Assalamualaikum and very good morning to everyone. Today we continue our chapter 5 on method of section. Basically, previously we have learned the method of join. So now we go into method of section. Alright. So the problem is same, but we are using different methods. Alright, student will be able to determine the force in truss members using method of section. Right. So application. So you see here the bridge. Okay, this is the bridge. So long truss are often used to construct bridge. Alright. The method of join require that many joints be analyzed, and therefore before we can determine the force in the middle of the parts. Okay. For example, you want to determine the force in the middle of the parts. Here you need to start with support and go all the way to the middle. So many joint you need to analyze until you reach the center. Right. So is there any method to determine this force directly? Right. So the answer is yes lah. Alright. So we have method of section. Alright. In the method of section, a truss is divided into two parts. Alright, into two parts by taking an imaginary cut as shown here as AA through the truss. So let's say you have a truss here. Okay. So we cut here. Alright, we cut this one. Alright. Known as a imaginary cut. Alright. So since truss members are subject to only tensile or compressive force, the internal force at the cut member will also be either tensile or compressive with same magnitude. Alright. So let's say we cut this one is tensile. Alright. We cut here. So the internal force is also in tension. So when we cut this one, it's become 2, right? So this one is tension, this one is also tension. So this one is compression. If we cut at this location, so this part is also compression, this part is also compression. Alright. Okay, when we cut this one, okay, this one is external force. External force. When we cut, there will be internal force, okay, with same magnitude but opposite direction. Opposite direction means if this one comes down, this one comes up, but the nature of the tensile or compressive is same. This one is compression, this one is also compression. Alright. Steps for analysis. Alright. First, so decide how you need to cut the truss. Alright, how you need to cut the truss. Alright. This is based on A, where you need to determine the force, and B, where the total number of unknowns must be does not exceed 3. Okay, previously in method of join, we do not exceed 2, but in method of section, you must does not exceed 3 because we have three equation, including moment. Alright, which is summation of x, summation of fy, and moment. Let's say at A is 0. Alright, we have 3 equation. Alright, so we cut here. Okay, determines on where you need to determine the force. Okay, in this example, let's say you want to determine the force for, let's say you want to determine the force FBC, FGC, and GF. Okay, so we cut pass through the all joint we want to, all member you want to analyze. Okay, we cut here. So you have BC, you have CG, and you have GF. So we cut here. Alright, pass through all the unknown, all the member want to analyze. Alright. Okay. Decide which side of the truss will be easier to work with. Okay. when we cut this one, we left with either we want to analyze on the left part, okay, on the left part here, left, or we want to analyze on the right. It depends on you lah. Okay. Basically we decide based on less number of unknowns. Okay, less number of unknowns, or you can choose any parts easier for you. Alright. If required, determine the support reaction. I suggest you do this. Alright, do this. Okay, at first. Right, find the support reaction. Like this way, we find the reaction at E and at B. Alright. Okay. So step number 4. Draw FBD for the cut truss. Alright. We need to indicate unknowns force at the cut member. Initial, we assume the force to be either intention or compression. Is it free choice? Alright. Upon solving, if the answer is positive, the member is as per our assumption. If answer is negative, the member must be in opposite. Alright. So like this one, if we cut this, so let's say we take the left part. Okay, we take the left part. So when we cut this, there will be the internal force. So we draw an internal force, FBC. Why BC? Because this one is B, this one is C. And then also they have this force, FGC. Why? Because the one is G and C. And also you have FGF, GF. The direction is up to you. Either you want to be this way or this way. It's up to you. Alright. So in this part, you have 1, 2, and 3 unknowns. So you can solve this using equation of equilibrium. Alright. Like this one, right part. Okay. We cut at AA. So you also have FBC, FGC, and FGF. Direction is up to you. Alright. For this one, you have 6 unknowns. You cannot solve unless you find first what is reaction here and reaction here. Then you can solve. That's why I suggest you to find what is the support reaction at D and E first before you proceed, so you can find the analysis at any part of the section. Alright. Number 5, apply the equation of equilibrium like I said just now lah. Alright. Choose the member with maximum 3 unknowns. Maximum 3 unknowns. Right. Okay. Let's go to the problem. Example. Loads are shown on the truss. The force in member G. Find the force in member GE, GC, and BC. Alright. So GE, BC, and GC. So the idea, the correct one to cut is AA lah. So before I go details, how we want to know the method we want to choose is method of join or method of section. Alright. If method of join, they ask you to find the force in all member. Alright, all member. So this one is suitable for using method of join. Okay, like we learned before. Alright. If the question asks find the force member GE, GC, and BC, specific member. So this one is method of section. Alright. Specific member. GE, GC, and BC, you use method of section. If they ask you to find all member, use method of join. Okay. So take a cut through member GE, GC, and BC. work with left part or the cut section, determine the support reaction. Okay, apply equation of equilibrium. Alright, so this is the steps lah. Or you can find first the reaction and then work with left part or right part. Easy lah. Right, first find the support reaction. Cut through lah, cut at A, right. Number 2, or you can find first the support reaction. Right, so you have here you have AY and then you have AX. So in here you have dy. So this is roller or ball, so only have one unknowns. So moment at A is equal to 0. Right, moment at A is equal to 0. So you have minus 200 times 8 minus 400 times 3 plus dy times 12 equals to 0. So you have dy is equals to, so take your calculator, so minus 1600 minus 1200, right, divide by 12, you get the answer 233 Newton. Right, 233 Newton. Okay, let me check again. You have 200 times 8 plus 400 times 3 divided by 12, 233 Newton. Right, and then find the AY. Okay, so summation of Fy is equal to 0. You have AY plus 233 minus 1200. Oh, sorry, I think there is mistakes here. And this one is not 200 but 1200. Okay, so you have 1200 times 8 plus 400 times 3 divided by 12. So you have 900. You have 900 Newton. Okay, so AY, we go again with this one. AY plus 900 minus 200 1200 is equals to 0. So you have AY is equals to 1200 minus 900, you have 300 Newton. AY is 300 Newton. And then do for Fs 0. So you have Fax plus 400 is equals to 0. So Ax is equals to minus 400 Newton. Alright, 400 Newton. Okay. And then we cut the truss. So we cut the truss here. Okay, so choose either right or left. Okay, let's say I choose right. Alright, choose right. Choose cut and choose side. Let's say I choose the right side. So you can draw again like this one. Okay, so you have this one, you have G, B here, okay, here like this, alright. So this A, this one you have AY, which is 300, and then you have AX this way, 400, right? Let's say change color, alright. And then you have GE, let's see this one. GE, you can choose any direction. GC, and you have BC, right? BC, okay. Right, so this one is 4 meter, okay. So here is 3 meter, right? So this is G, and this is B, okay, and this is A. Alright, so now we can choose okay, now we can do the analysis using equation of equilibrium. Okay, let's say you want to choose which point. Alright, you want to choose which point. Let's say I start with find moment at B at G. Alright, find the easiest moment. So summation of moment at G is equals to 0. Alright, so 400 times 3, okay, clockwise. Clockwise is negative, and then negative 300 times 4 also clockwise, okay, and then plus BC times 3 counterclockwise, which is 0. Okay, alright. This one is same if we draw like this. Okay, so you have GC and you have GE here, right, and you have BE. Okay, so if you left this as triangle to the lies, alright, you left this as triangle, this triangle, alright. Okay, so BC is BC, oh sorry, so BC is equals to minus 400 times 3 plus same lah, alright, divide by 3, you left with 800. Okay, 800 Newton for the BC. Alright, FBC is 800. Is it tension or compression? Is going pull the joint, so is it tension? Alright, so we can do the same with the summation of Fx. Summation of Fx is equals to 0, so you have minus 400 plus BC is 800, and then plus GE, okay, and then plus GC cos, how much is it? So you have here 4 and 3, so this is 5 lah, right? So if I draw this one is 4 and this one is 3. Okay, so GE plus GC 4/5, here is 5, 4/5 G C is equals to 0. So equation number 1. Okay, so then summation of Fy is equals to 0. You have 300 minus 3/5 GC is equals to 0. So you have GC is equals to 300 times 5/3. So you have 500 Newton. Positive 500 Newton. So GC going out from the joint or pull or push the joint or pull the joint. So you have tension. Alright. They pull the joint. They pull the joint. You have joint. They pull the joint is tension. If the joint, you push the joint is compression. Right? So GC, you take GC, you put here, you got the GE lah. Right? So GE is equals to 400 minus 800 minus 4/5 GC, which is 500. So you have GE is 400 minus 800 minus 4/5 times 500. You have minus 800. Minus 800 Newton. Minus means the direction is actually this way. So they push the joint. Is it tension? 800 Newton is tension. Right? So you have all the answer. Alright, now we go into next problem. I think this is problem number 8. Problem number 9. Problem 9. Alright. Okay, you have a loading on truss action. The force in find the force in members BC, BE, and AF. So they specifically tells you what member you want to find. So this is the method of section. Alright. First, find reaction at support. Reaction at support. Number 2, cut the interest section. Okay, number 3, draw FBD lah. FBD at right or left. Number 4, solve. Okay, so BC, BE, and EF, where is it? So you have BC, BE, and EF, this one. Okay, so you cut BC, BE, and EF. So you cut this one. Alright. The cut region is not necessarily straight line. You also can cut. Let's say you want to find other joint. You also can cut like this. If let's say they ask you to find FG, BG, and AG. Okay, so you have FG, BG, and AG. You also can cut like this. Okay, it's not necessarily straight like this. You can also have a curve to cut the section. Alright. Okay. Let's start lah the analysis. Okay, when you cut this one, okay, find the reaction first. So you have I think I will make another slide, right? Right, we cut this one. Okay, so find reaction at A, Y, AX, and G, Y. Okay, so find the reaction first. Okay, so summation of MA is equals to 0, Okay, you have minus 10 times 4 minus 10 times 8 minus 5 times 12 minus 5 times 4, right? And then plus gy times 4. So you have 0. Gy is basically is equals to 40 plus 80 plus 60 plus 20. So you have 200. Gy is 200 Newton. Right. And then summation of Fx is equals to 0. So you have Ax plus 10 plus 10 plus 5 and is equal to 0. So you have Ax is equals to minus 25 Newton. Right. Or 25 kilonewton lah, kilonewton to this direction. Alright, so you have assume this direction, so you get negative, so this is opposite, right? And then summation of Fy is equals to 0. So you have Ay plus Gy is 200 minus 5 equals to 0. So Ay is also minus 195 kilo Newton. Alright, or 195 kilonewton to the bottom. Alright, okay. And then we finish, find the direction at support. Okay, and then we cut. Okay, we cut this one, and then you choose, you want to choose the upper side or lower side. It's up to you. Okay, it's up to you. Let's say I choose the upper side. Okay, you choose the upper side. Cut and choose upper side. It's up to you. You want to choose lower side, right? If we redraw, we have like this, and we have here, and we have here, right? You have 5. We have 10. We have 5 here, right? And then we have direction. So I use different color. You have CB, and you have EF, and then we have EB, alright. You have EB. This is 4 meter. This is also 4 meter. So this is 45 degree lah, right? So this one is 45 degree. Okay, 4 meter, 4 meter. Okay, and then it's become easy. So this is point G, point E, this is point C, and then this is point D, right? So find moment at E is equals to 0. Why moment at E? Because they have two unknowns here, 2 force or 3 force including 5. So this force is contribute 0 to the unknowns. Okay, and then you have find a moment at E is equals to 0. So you have minus 5 times 4 clockwise, and then plus CB times 4 is equals to 0. Alright, that's it. Okay, so this one 0 moment, this one is also 0 moment. Okay, because it's passed through this point. Alright, we left only CB and 5. So CB is equals to 5 kilo Newton, right? So direction is positive, so we assume here is correct. So pull the joint is tension. Tension. Remember, we have joint, push, compression, pull, tension. Right? And then we left with find the summation of fx is equals to 0. Alright, so you have 5 plus 10 minus EB cos 45. Alright, why minus? Is go to the left, it's minus. This one, if it cos, is go to the left, so it's minus. So you have EB is equals to 15 divided by cos 45, 21.21 kilonewton. That is for EB. Alright, so direction is true as per our assumption. So this is tension. Pull the joint, tension. Alright, and then we go to the summation of Fy is equals to 0. So you have minus 5 minus EB cos or sine 45 to 2.21. Oh, sorry, not 2.21 but 21.21. Alright, 21.21 sine 45, and then minus EF equals to 0. So you have EF is equals to 5 plus 21.21 sine 45. So you have 20. EF is it 20? EF is, so you have 5 minus 5, or CB. Oh, sorry, I left it CB here. So CB is 5 also, so minus 5. Alright, so you have here you have 5, and you have CB, and then you have EB sine 45. So minus 10 plus 21.21 sine 45 minus 10 minus 21.21 sine 45, you left with 25 kilonewton. Right, negative. So negative, that's mean direction is opposite that we assume. Alright, opposite that we assume, so it's become compression. Alright, so EF is this way, right? It's push, so it's compression. Right, so you get the answer. EF, EB, and CB. Alright.